And we are also starting about 5 minutes late as well. So let me share my screen first.
Good afternoon, sir. KP Sharma.
अरे गुड आफ्टरनून सर.
कैसे हैं सर?
बताइए, आप बताइए.
बस ठीक है सर.
All right, okay. I think quite a lot has been covered, but जब मैं screen share करूंगा तो probably I will not be able to see you. All right, so let me. बाकी लोग तो अभी अपना कैमरा बंद किए हुए हैं, but okay, fine.
हाँ, कैमरा तो बंद ही रहेगा सर.
हाँ नहीं ठीक है.
हाँ,
It is
माइक भी
much
बंद
better
रहेगा,
that-
हम आपको ही सुनेंगे अब. राइट सर.
It is much better that way.
यस.
तो बेसिकली ट्रेनसेट का काफी कुछ कवर हो चुका है, लेकिन मेरी 2 क्लासेस हैं इसमें. एक तो इट इज रिलेटेड टू कंट्रोल सिस्टम. इसमें क्या है, हर मोटर कोच का एक अपना अलग से कंप्यूटर है. एंड आई विल शो यू ऑल दैट. जस्ट होल्ड ऑन अ सेकंड, लेट मी शो दैट. लेट मी फर्स्ट रिक्लेम द होस्ट स्टेटस. ओके, इट इज विथ मी. ऑलराइट, and share the screen and where that is. Okay, I think it should be visible to all.
यस सर.
Yes, sir.
Okay, I'm trying to make it full screen. Let's say if the full screen works here. Okay. Now full screen is working.
यस सर.
Sir.
Okay. So now straight away let us get on to the subject here. The train line communication and TCMS, right? It also includes control. Now there are 3 types of control in this. Basically there are redundancies. Basically there are so many redundant systems in train line, and some of that must have been covered by now, that like our normal train, most of the time your train set is not going to fail at all. Now, I think this difference must have been covered in the session so far. What is the difference between train 18 and train set? Has it been covered? It has been addressed? Anybody? Need feedback? The difference between train 18 and train set. Anybody, please. Sharma ji. At least आप तो सुन रहे हैं, पता है. Has it been covered? अभी तक ये कवर हुआ है क्या?
नहीं सर,
That
कवर
would be-
नहीं हुआ अभी.
ओवरव्यू थोड़ा सा मिला है सर, पूरा कवर नहीं हुआ है सर अभी.
Okay, okay.
proper
There is
concept
very
of
minor difference actually. You may remember that the concept of train set was initiated way back in 2015, 2016 kind of that during that period. In fact, this thought process was going on for quite some time, but ICF started a project, and they released the first train set in 2018, and they completed this whole thing in 18 months. So Mani sir was GM and Subhranshu sir was PCME there, who actually coordinated about this whole project, and in very record time the whole thing was made and released. So there was this both connotations are there, that 2018 and then 18 months of completion. So they simply called it train 18. But all the future rakes will be referred to as train set. Train set, that is a standard nomenclature for that. No more train 18, and there is a lot of difference also. जो पुराने रेक जो रिलीज हुए थे, and the new rakes which are going to be commissioned now, one was about to be completed. I don't know. I think it has not been released yet. The third rake was nearing completion in ICF. So all the future rakes will be called simply train set. It will not be train 18, but because there is a lot of lot of difference in the standards also. Some modifications, some reliability issues have been sorted out, and so forth. So everybody is okay in English, or should I try to cover more in Hindi?
Sir,
Any
English
feedback on that? English is okay with everybody? Okay,
हिंदी
fine.
सर
नहीं, if there are people from South India, then थोड़ा सा problem हो जाता है उनको. So
Yes, sir, exactly.
okay,
Sir.
fine. Yeah. No, I don't know who is telling that, because once it is full screen, so you don't have to, please don't type anything. This is one of the problem with this WebEx is you type anything, I will not be able to see. You please speak, right? And oh, all right, okay, fine. So let's get on with that. So I think this should be very clear. It's very minor difference, very insignificant difference, but that defines how the new rakes will be called. It is all Trainset now, which is anyhow it is an international description of the EMU that runs for longer distances, bigger rake with better comfort. It's called Trainset. Now all the high-speed railways are running with Trainset. Probably this would have been covered. I think there was a class on high-speed railway. It has been covered, no? That if you want to go anything beyond, anything beyond 160, 180 kilometer, and 200 kilometer per hour is absolute limit. Beyond that, you can't go with locomotive. So you need to have distributed power. And you want to go for, even this Trainset, even though it has been certified for 160 kilometer, right now, as you may be well aware, you are aware, na? The highest speed potential as of, highest certified speed as of right now for the Trainset is 160 kilometer per hour. Yes, no?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
But the potential for technology is beyond 200 kilometer per hour. Even with the same technology, with the same bogie, with slight optimization, this Trainset is capable of going beyond 200 kilometer per hour. That means it is right now it is semi high speed train. High speed train means there is a UIC this thing. The UIC definition of high speed railway. 250 kilometer minimum on modified railway lines, specifically built. No, for specifically built railway tracks, and 200 with modified lines, and 200 with exemptions at bridge, embankment, curvature, city limits, etc. So 200 is bare minimum for any train to be called as high speed. So we are not into that territory. So we simply call it semi high speed. But this technology and this rake itself has the potential to cross 200 kilometer per hour. The ICF is quite certain about it, provided our track system, the infrastructure supports it. So clear? Now, if you want to go beyond 250 kilometers, then stainless steel may not be the material of choice for construction of the coach cell or the body of the train set. Aluminium, yes, you have to reduce the axle load. You have to further stiffen the suspension system. Further track needs to be undulation and those things needs to be controlled to much higher standards. Then definitely there is a clear path how the trains can run at 250 or 300 and even 350 kilometers. But right now, considering everything, it has been certified only up to 160 kilometers per hour. Okay, so it is distributed power. And in locomotive, we know that it is like a black box. Everything is contained inside a single vehicle. And whether it is traction control, whether it is the brake application, whether it is the control, whether it is the safety system, whether it is the fault tolerance, the standby systems, backup system, that is, everything is contained mostly in the locomotive. The coach's safety and brake system, except everything else is in the locomotive. Now here it is distributed. So how it is all controlled by the locopilot? Let me repeat that. How all of that is controlled by the locopilot, how the communication takes place. In case of locomotive, everything is contained in a single vehicle. The control, the connection cannot be broken. Here, what kind of setup is available that safely communicates, and in case of any disruption in that communication or the signal, how these systems behave, how safety is built into that, all those things we are going to cover in this. The questions are welcome. You can ask at any time. कभी भी आप पूछ लीजिए प्लीज, बीच में ही पूछ लीजिए, don't wait for the chapter to end and then only ask in between as well, right? So now let us start with that. Okay, this is the driver's cabin, and if I can write here, it's my pen. Okay, it's not okay. Let me. Can I find the pen differently? Oh, okay. Found the color, right? Now, which side driver sits? Locopilot. Which side locopilot sits? Anybody?
Right side.
Left side, right side?
Left side.
Hanji?
Left side.
Left side.
Left side.
In our locomotive, the locopilot sits on left side.
Left
So you
side.
can see this seat belongs to locopilot, and this seat belongs to, as usual, what? ALP.
Co-pilot.
Absolutely. Co-pilot or assistant locopilot, right? Okay. No, it depends whether you are sending two locopilots, then it is pilot and co-pilot, and if you are sending one LP along with one assistant, then it is ALP. Now, the system can be controlled very well by only a single person, but as far as rules are concerned right now, and hold on, yeah, this is another one thing. You start writing by pen and then you lose your mouse. This happens a lot with okay. I stop annotation, then I get my mouse back. All right, okay. Now you can see sometimes it looks like a master controller, but it is not. It is just a microphone. The master controller is here, that is small one you are looking at it. Can everybody identify that? A small handle, it's like a T handle that is in front of the, at the middle of actually control desk. So the locopilot sitting on left side can control it with his right hand. All right. Now there is one more handle. Now I lost my mouse again. So just give me a second. I will try not to draw anything on the screen because okay, at least I got that back. All right. So there is one more thing. Let me still draw that. I think there is one more, one TFT. it is only in front of loco-pilot and not in front of co-pilot or assistant loco-pilot. You can also see one more handle, that is auto brake, that is last resort pneumatic brake, that is not supposed to be operated at all. Right? Is it identifiable to you all?
Yes, sir.
Yes, sir.
Okay. So there are few things. We have seen a master controller which is at the center of desk, a TFT touch screen which is in front of Locopilot, right? And there is one limp mode pneumatic brake at the end, which is basically in a isolated condition most of the time, all the time, in fact. So now that is we will just forego the rest of the button. We will not get into that because those things are hard buttons. Those things are for operation of the train set. But the handles, the TFT screen, these are very, very important, and we will be discussing that further. It is quite comfortable. You can see the driving cabin is quite comfortable. There is a separate AC. There is a separate 2-ton AC, which is specifically for the driving cabin, and they can go to the passenger compartment. There is a door behind them, so they can simply leave the driving cabin and go to the passenger compartment and utilize the toilets or the toilet system available in the passenger compartment, right? So the level of comfort for the loco-pilot and co-pilot also are very high. Now you may remember that in locomotives normally we don't have any such thing. In very, very recent locomotive, there are few designs in which the toilet is built into the locomotive. That is only for urinal actually. But rest of the time and all the other design, up to quite recent times, there is nothing for the loco-pilot. They will have to stop the train or go to some station facilities. So where the comfort level of loco-pilot and co-pilot is concerned, it is very good. So that is one, but we are not going to talk about the comfort level of loco-pilot, though it is an issue. So let's get on to that. Okay. Now there is another one. The coupling is very, very, it's not easy to decouple. It is not easy to decouple a coach and change it. Has it been covered that if a train set is to be become defective, not able to run, you need another train set as a replacement? So most of you, anybody is from loco side or all are from the CNW side? I need some feedback. Few can reply.
Sir, I am from local side. Avinash Das,
Oh.
SSC GRC, Southeastern Railway.
Golden Rock.
No, sir. GRC Southeastern Railway, sir. Garden Reach.
Acha, Garden Reach.
Yes, sir.
That is, I thought GOC SR. Okay. But
Okay,
you are from the loco side, HHP loco or conventional Elgo loco?
Sir, HHP loco.
Then some of the things that are in this will be much more familiar to you.
Exactly, sir.
But some of the things are, a little new for the people who are purely from the CNW side. But the people from the CNW side, you all know the concept of spare coaches. Yes? Yes, no, need some feedback at least.
Yes, sir.
So what is the, okay. So let me hazard this question also. Let me ask you, what is the latest spare percentages? AC and non-AC?
Traffic and
5%.
4%.
Traffic and total बता दीजिए. Traffic and maintenance you are telling separately.
9 for AC, sir, and 11 for AC.
9, yeah, exactly. 9 for non-AC, 11 for AC coaches, right? All combined, everything now. Right, okay. So the concept of spare coaches is when you run a rake, if any of the coach becomes unfit to run, you simply remove that coach and replace it with the similar coach, right? Exactly of same type of coach, and your train is ready to go, right? But same thing cannot be done here because coupling and uncoupling is very, very difficult here. Now, what are the things that you are going to couple? 25 kV HT cable you are going to connect, right? Except for a DTC and one motor car. Behind the DTC, there is one motor car. So extreme end में formation you would have already studied. Formation is 16 coaches, right?
Yes, sir.
Yes, sir.
Okay. Yes, sir. This has to and there is a basic unit of 4 coaches. In a basic unit of 4 coaches, there are 2 motor cars and there are one trailing car and one driving trailing car or non-driving trailing car, right? DTC or NDTC, right?
NDTC.
So those are the basic unit will have. This is a unit of 4 coaches, right? And this basic unit is self-contained. So you require at least 2 basic unit to form a train. Right now, the train is of 16 coaches. 16 coaches, and they have to do some changes in the software to permit the train of 8 coaches. That will be 2 end units, right? Or 12 coaches, that is 2 end units to 1 middle unit, or 16 coaches, that is right now the default 2 end units, 2 middle unit, right? And even 20 coaches, in that there will be 2 end unit and 3 middle unit. All those combinations will be possible with the upgradation of software in future. But right now, by default, it is 16 coaches. 16 coaches of 4 basic unit. Each basic unit of 4 coaches. I think this up to this it has been covered. But how they are coupled? Uncoupling is very, very difficult. Why? Because you can see how much of, if you are from C&W side, you know how coupling is easy, right? By LHB में थोड़ा सा intervehicular coupler has come nowadays, IVC. So you have a coupler at the center, one IVC, one BP, FP, and matter over, right?
Yes, sir.
Here,
Yes, sir.
and all are with quick coupling and quick discoupling. Here the couplings are mostly permanent. There is HT cable on the top, that is 25 kV. Except for a DTC and one motoring coach, at the both end, rest all other coaches are connected with 25 kV cable on the top. Then there is a and G coupler, right? A and G couplers are basically, it is network couplers. All the network digital communication are through this. Then there are F1 and F2 coupler. For most part, this is train line signal. There is a 40 pin F1 coupler and a 30 pin F2 coupler, right? Cable is actually 2.5 mm square cross section area. Those A and G coupler, those are Cat 5 standard cables. Then B1, B2 coupler, they are basically for 415 volt auxiliary power to couple the coaches, right? That is heavy cable, of course, it is 35 mm square. Then we have 110 volt battery connection, right? There are C and D. Sometimes only C is required. Sometimes C and D both are required because battery direct and battery normal, I think it has been covered already, right? So those are battery connection. Then you have power cable. It's huge, right? 120 mm square. Those are actually 1200 volt AC connection. It varies depending upon the OHE voltage. In propulsion circuit, I think it must have been covered that at voltage at which the line transformer steps down varies a lot, right? It could be anywhere from 600 volt to 1100 volt, right? Yes, no? Anybody? I hope I am audible.
Yes, sir. Yes, sir. Audible, sir.
Right. See, this OHE is how much voltage? Anybody?
25 kV. 25 kV.
25 kV, yes.
25 kV.
है ना? Like your domestic supply, it is supposed to be what, 230 volt, right? But do you get exact 230 volt in your domestic supply?
No, sir.
Oh.
220,
Varies.
240.
Depends. There are a lot of other factors that how much load is there any phase imbalance, right? And all those things. Settings at transformer. Sometimes they want to keep the voltage slightly on higher side. So with load, it drops down to 225, 230 volt. And if there is no load, then suddenly you will find it is 240 volt, 242, 243 volt. So it happens in your domestic supply. It happens a lot in your OHE. So rather than 25 kV, it could go down to 19 kV, 18 kV, 17 kV. And upper side, it can go up to 30 kV. So this train 18 is capable of running from 16 kV to 30 kV. But it is good between with full efficiency and everything between I think 17 kV to 28 or 29 kV. So 25 kV is nominal. It should be standard, but it is not. So therefore, this this P1, P2, P3, P4, where this must have been covered that trailing car has got LT line transformer, power transformer, step down transformer for 25 kV. It is in trailing car.
Yes, sir, it has been covered.
Okay. Why these components are distributed as such?
During starting and
To balance the load. To balance the load, because step down transformer is a solid copper block. हाँ जी कुछ बोल रहे थे?
reduce the weight in
distribution.
vehicle.
No, we cannot reduce the weight, but we can distribute it. So
Uniformly,
it can be,
uniformly
it
distributed.
can be uniformly distributed. So the heavy items are kept in the where the motors are very heavy. Yes, we know that. So wherever there are motors, they didn't keep the transformer. So they keep transformer at the center. This transformer provides supply to both side trailing cars, so that that power connection should exist. So that is what P1, P2, P3, P4s are. And then there is a Delner coupler. There is a lot of issue of very high jerk in case of this CBC couplers, right? In train running, etc. You may be aware, people from C&W side, whoever are maintaining LHV coaches are well aware about that. The problem of jerk while accelerating, deaccelerating, braking, starting, and so on. Though those things are non-existent here because of the Delner coupler, but the downside is that you cannot simply disconnect this coupler easily. It is like Saku coupler. It is just like Saku coupler, slightly less in diameter, more powerful, but and with proper torquing tools only you can make the coupler or remove it. It's not very easy process, right? So that's why it is called semi-permanent coupler. It is not permanent. It is detachable in any case, and it is designed to be detached and attached. So that's why it's called semi-permanent coupler. So you look at all those electrical coupling, then the semi-permanent Delner coupler, right? Power cabling, and then there is a BP and MR that also is available. Why? As a last resort, BP and MR both are available, and I'll explain what that is. Now that also gets coupled. So and there is a vestibule, and there is a vestibule. So vestibule is very securely connected. It's not like the vestibule in ICF coaches or LHB coaches. There is a dual layer cladding is there, and baffle plate are available. Brackets are available at the both head. Initial train 18 design में there are more than 15 bolts which needs to be tightened. कुछ बोल रहे हैं?
Just only supply में आना नहीं आया, supply में नहीं आया. Supply.
Nagesh Yadav, could you please switch off your microphone if you are not speaking here in the class? Okay, right. So it would be nice that if you want to speak, just switch on your microphone, speak, and then switch it off again, right? So that way we will not have any echo, and any unintended discussion may not reach into this classroom. Fine. So by looking at all these things, I was talking about this vestibule area, and then so in the latest design, in rest of the train set, it is only 4 bolt and some sort of bracketing that they have designed. So it can be easily disconnected and connected, but still you will require a support, pre-hanging and clamping and then mounting of 4 bolts. It is still not that easy. So the point that I'm trying to make here is disconnecting these coaches from one another is very, very, very difficult. Right? Just look at it. You will know. And these couplers, why I have listed here is what is the purpose of this coupler, particularly electrical connections for controlling train, that we are going to discuss next. So, am I clear? Any question till here? Anybody? Yeah,
No.
point about spare. Then how do we maintain a spare for this? Nobody has got that question. Nobody is asking that. Yes. How do we maintain a spare? Yeah.
Basic unit wise they will replace, sir, not coach wise.
Oh, I'm sorry. Just yeah.
Like PLC wagon units.
Initially, when the rakes are less, the whole rakes have to be kept as the plan is to keep the whole rake as spare, right? But later on, I'm very sure for economizing, it will be basic unit that will be thought about to keep it as a spare. But right now, the plan is what the ICF is recommending, what the zonal railways are planning to keep the whole rake as a spare. Of course, this rake will be, spare for several rake. It is not that you should have 50% spare. That means you are 100% spare. That you are running 1 rake, you keep 1 rake spare. If you are running 10 rake, probably you will keep 2 rakes or 3 rakes spare. Now, unless there is a very, very severe mechanical problem, these coaches are designed, the propulsion system, the coaches, the air brake system, the control system, they are designed in such a way to ensure almost zero failure, very, very high reliability. And we will see that how it is so. How many traction motors are there? Anybody? Because propulsion circuit is already over. How many traction motors are there in total?
32.
Huh?
32.
Yeah, 32
sir.
32.
traction motors, right? And you would think some of the bogies are isolated. Now these are in pairs. One traction motor cannot be addressed separately. They are operated in pairs. So you can say there are 16 motor units. Each unit has got two traction motor. So that you can disconnect the whole bogie, isolate it. Some of the motors fail. There is a problem. Any kind of problem, you can isolate the whole bogies. Bogies after bogies. There are 16 bogies which are powered, right? In quite a good number of them, you can isolate and your train will still run. Acceleration and deacceleration will still it may be slightly less if it is about a quarter of the bogies are disconnected, but still the train will run and it will still reach its high the full speed potential. And there are other things like the compressor.
Bogies or
Only 3
coaches?
compressor.
16?
Ajit?
16 bogies or 16 coaches?
16 bogies are powered. 16 coaches, 8 motor cars, 8 motor cars, 16 bogies. 16 bogies are powered, right? Each bogie has got two motor, but these motors are not controlled separately. Whether it is the traction computer, right? Or it is the isolation of motors, or it is traction control, or it is the IGBT based this inverter which powers these motors. These two motors are connected parallelly. In the propulsion circuit, two motors are connected parallelly. So each bogie is controlled separately, not the motors. There are 16 bogies. 8 motorized coaches, no? Am I clear?
Yes.
Okay, right. Okay. So now electrical connectors, you see that we will just go over that. Electrical connector is a basic unit to basic unit. There is a slight difference. Like battery power, this normal and direct both is not required from basic unit to basic unit. So only decoupler will be connected. But apart from that, train line coupler F1 and F2 will definitely be connected. This network connector, that is Ethernet, audio, right? There is audio, this thing streaming. There is a passenger information system. There is a passenger emergency communication unit, we have alarm. The passengers can speak to Locopilot using this specialized unit panel that is available. That's called PECU. Right? Then there is a CCTV cameras and recorder for that. Locopilot will be able to monitor anything. So all these signals are communicated using this network coupling, right? And the most important, I should have highlighted it or put it in red, brake. It's an electronic brake system. You don't reduce the brake pipe pressure to apply the brake or release the brake. You actually communicate this through digital signal. And this is also three ways. There are twin digital loop circuits are there. And then one frequency based system also is available. We'll see about that. And that is RDM for rescue drive mode. And you don't have to, modulate brake pipe pressure in order to apply the brake. So those signals are also communicated through that. So it is A and G. Here it is AG1 and AG2. Depends on where it is coupled. Then there is a aux power. That is B1, B2. Of course, there is a redundancy. This B1 and B2, there is a 100% redundancy, right? Then the battery power, and then of course 25 kV on top. And in case of between the basic unit, that means among these four coaches, how they are connected. Basically, it is F1, F2 train line signals will be available in any case. This thing is not called AG1 and AG2. It is called A and G. That is again, but signaling is more or less similar. Aux power, of course, same. Battery power, it is both are there because battery normal, battery direct. For that we have twin brackets, and of course 25 kV. So you can see with slight variation, the type of coupler that is quite similar. Here, the TC2 motor car, only difference is you can see here it's a power cables P1, P2, P3, P4, right? Rest other all things are same. Right? It is trailing car to motor because trailing car has got a line transformer, and then of course that step down voltage has to be carried to motor car. Motorized coaches, that is. And then we have pneumatic connections also separately, that is brake pipe 5 kg and MR pipe 10.5 kg. That has the nominal pressure. MR can work for all the way from 8.5 to 10.5 kg. 10.5 is upper one. And then brake pipe of 5 kg. Why we maintain brake pipe when we have EP brake, electro-pneumatic brake we have, then why do we maintain brake pipe, train line brake pipe? Anybody?
In case of during low speed, is required
Pardon?
control pneumatic braking.
If train goes below 30 kmph, it requires.
No. If you are using that, the train speed will be limited. See, your normal control is only through EP brake, electro-pneumatic brake. Your normal control is through electronic
So it may
signal
be
or application
the
and
last.
release of brake. If your one channel fails, there is another channel. Again, that is electronic brake. If all the channels fail, right, then you can physically control by modulating the brake pipe pressure. Similarly, that is happening right now. You reduce this pressure and brakes will be applied. Now these brakes will be covered in proper detail in another one of my class, I think it will be on Friday because I was not able to take this class today. So there was some slight reshuffling. As per the timetable, it was today, but it will be on Friday first class. We will cover in great detail all the brake system, suspension, air spring, its effect on the, you might, I think in the overview, it must have been covered this also. Depending upon the weight on the coach, the retarding effort is actually biased, right? So brake application is again dependent on the weight of the coach. If one of the coach is heavier, definitely you need more braking effort there, right? And if the coach is lighter, you need less.
Voice is not coming.
Which is used to apply the either the motoring or the braking. If you push it in the front side, it is motoring. You pull towards the driver, and then it is braking mode. So a single handle is used for both purposes. You leave it at the center, then train will be coasting, right? You are accelerating. Move the handle to center position. The train will have neither motoring nor braking. Then you pull towards the loco pilot side, and then the brake application takes place. Again, it is dependent on how much you move the master controller. So there is a single master controller which controls the acceleration, speed, and braking, all. So this auto brake, which is again for limp mode only, if everything else fails, then for that this brake pipe is given. Now the thinking is right now, because it is mandatory as per the rule that train line signal 5 kg for BP. These rules are to be modified. This can be dispensed with. Even in case of train parting, there will be loop back digital signal that will be lost, and it will again will be detected by the system, and the brakes will be applied. So in case of parting, brakes should automatically get applied. It can happen purely on the electronic side itself, and there is a redundancy also. So this thing can be completely avoided, but right now there is a requirement under the rules also. So this system has been kept. So there is a brake pipe. It runs throughout from the first coach to the last coach. And then MR pressure is available because compressors are available. There are 4 compressors, 1 per basic unit. Where they are fitted? Anybody remembers that? Where these compressors are fitted? Again, it will be covered in greater detail in air brake system, but still just to drive a point home.
DTC and NDTC.
Yes, it is available in DTC and NDTC. So, and there are 4 compressors. Any of the 3 compressors will be running at any given time. When the train starts, when it is priming up, when it is just booting up, that time all 4 compressors work. Once the pressure has reached, then any 3 compressors work at any time. And if up to 2 compressors can fail, 2 compressors can take load of the train while running. So see how much of redundancy is built into that. 4 में से अभी loco में, in a loco, if a single compressor fails, what happens? Anybody from loco side at least? In a locomotive, if a compressor fails, what happens?
Sir, there will be no braking, sir, because there is only one compressor in locomotive.
That's all. Loco fails. It can't
Yes,
do
sir.
anything. You need another loco to run the train. That's all.
Yes, sir. Yes,
Over.
sir.
In case of electric locomotive, all the new design electric locomotives have got 2 compressors. You may be aware, right? So the purpose
Yes,
of
sir.
2 compressor is if one of the
Alstom
compressor
has got
fails,
2 compressors.
the another can pull through, right?
Yes, sir.
Here up to 2 compressors can fail and still your train will run. In normal itself, 1 compressor will be kept isolated, and there is a logic which keeps on rotating the idling compressor. So it runs for a certain number of hours, then that compressor starts and another one is switched off, and that way. So yes, that when we talk about redundancy, the train is very well equipped. So what are the things that comes in TCMS? Train Control and Management System, right? This control motoring, braking, direction, reverse, front, and so on, right? It runs in either side. Both side is front actually, right? Only it is a direction, B direction, right? The control of door, right? These locomotives are fitted with sliding type automatic doors, which needs to be closed completely for the train to even start. हमारे यहाँ क्या होता है, दरवाजा आधा खुला है, अरे लोग तो दरवाजा खोल के अच्छे से बाहर झांकते हैं, थोड़ा हवा लगता है, right? This happens, you know, we are very happy standing on the door and getting fresh air from the outside. That cannot happen here. All the doors need to be locked completely, and then only train can run, otherwise train will stop. Hold on a second, please.
आवाज नहीं आ रहा है.
हाँ, आवाज इसलिए नहीं आ रहा है, थोड़ा एक अर्जेंसी था कुछ और चीज में. जस्ट आई विल बी बैक, जस्ट गिव मी 30 सेकंड प्लीज, राइट? ओके.
Okay, sir. No issue.
We have to take 10 minutes break in between the each class. Normally we keep it 5 minutes. There is a very another exigency. Everybody can have tea and come back. Would it be okay? Within
Yes, sir.
within 5-7
Yes,
minutes.
Yes, sir.
Okay, sir.
Okay, sir.
Okay,
Okay.
join back in 5-7 minutes, right? Okay. I'll join back. Sorry about that. I think at least 3-4 minutes are over. I know it is not 7 minutes, but and we have to cover also a lot. So sorry about because there was an interruption, and I'm also in charge for all the online systems of IRIMEE. So there was some other problem, other classes had stopped. So okay, let us continue with that. If you are still having your tea, you continue that. Just listen to me. Should it be okay? So okay, so we were talking about that. What are the different things that TCMS does, right? So this is of course control of motoring, braking, that is by a single handle. Direction, there is a separate key for that, right? Control of doors. These doors are supposed to be doors are required to be completely shut off before the train can start. Of course, there is some problem with the door, mechanical failures, the problem of sensors. These can be isolated in the control system. So the control system won't bother about that particular door, one door or more than that. Control of AC. Now there is a AC control panel is available in each coach, and if required, AC attendant can control the cooling of coach independently. But on the other hand, if required, it can be controlled centrally. You don't require any AC attendant as such, as of this train is concerned, right? So this thing can be done by the TCMS. Then there are automatic control like blended brakes. Blended brakes is basically a combination of pneumatic brake, that is basically electro-pneumatic brake, and dynamic brake, and it is calculated automatically, right? And this dynamic brake, there are certain speed ranges in which it is more effective. And there are other reasons when your grids become hot, when there are not enough this thing. There is no receptor for that, when the electric power cannot be consumed by the OHE. So those cases are there where the amount of dynamic brake can be reduced, modulated, and amount of pneumatic brake can be increased to such an extent where the dynamic brakes become zero and 100% pneumatic brakes come into play. So all those controls are automatic. Locopilot doesn't even bother, right? This we'll discuss in the, as I said, in the brake class. But again, this control is also by the TCMS, right? The feedback loop is with TCMS. Now the rotation of compressor. What else? Okay, where am I? This is the same driving cabin from the other direction. At the risk of losing the mouse pointer again, I'm just going to draw that. This you can see TFT touch screen. This is the master controller, right? This is the speed recorder. मेधा का पुराना वाला जो लोकोमोटिव में होता था. This is ALP panel, right? This is ALP panel. Door controls. भाई स्टेशन में गाड़ी जाएगा तो somebody has to open the door or close the door. There is a safety built into that, right? Direction control. So everything is kept in the arm's reach, very well layout. The control desk, right? So this is just a few items which are the LP side and ALP side. Like there are a lot of, and it is for most of the part, like in case of door opening, you know, what is the minimum condition that is required for a door to be opened? Anybody? What is the first requirement for the door to be opened?
The brake should be fully applied.
Actual speed should be 0.
Speed should be 0. Yes. Speed should be 0, right? The train should not be running. For train to start, door should be closed, but for door to open, speed should be 0. All those things. And even with that, by mistake, you should not be opening the door or closing the door. For that, there are two buttons. They must be pressed together. They must be pressed together in order to either open the door or close the door. So you see the chances of mistake, by mistake, your pen, you are putting on the desk, somehow you by mistake press the button. Nothing is going to happen, because then you have to intentionally either open the door or close it. So you have to press two buttons separately together. So those kind of things are built into the control. Okay. Okay. I have to disconnect the annotation. Go to next slide. Okay, let me see that. Right. Panto and VCB setting, of course, downing we can do, rising we cannot. There is a separate button for that. So the Panto setting, there is one pantograph in each basic unit. So there are 4 pantographs. Only 2 of them can be controlled together. Yes, no, anybody? Huh?
Yes, sir. Only two can.
So what is the combination? Which panto can be operated?
1 and 4, 2 and 4.
2 and 3.
1, 4, 2,
1,
3.
4, 2, 3.
Yeah, exactly. So this setting is available here. Go to next. Bogie cutout. People from the loco side may know that motor cutout procedure. In Elco locomotive, there used to be one handle, right? This thing, MC cutout, handle we used to call it. So in later generation software control, you could control from your display. The same thing is available here. You can isolate any of the bogie. You can isolate any of the bogie from the same your DDU. It is called driver display unit. It is a touch screen. Okay. Now basic unit isolation. Not only that, you can isolate the whole basic unit, right? So if you isolate, that's all. Power is not available for traction, but the power will be available for auxiliary by basic unit, because of technical problem, because of some technical problem might have isolated basic unit, but there may be passengers. So all passenger comfort thing will still be on, but all the things related to motoring, traction would be isolated. Right? Okay. So we have a system of BU isolation. Then it also maintains the compressor control, right? Individually you can control, that is 4 compressors are there. All you can on, or you can switch off any specific one, or you put it on auto, then the computer decides which compressor has run most, so that can be switched off. EP brake isolation, that can be done here. Like we have bogie cutout cocks are available. Those are available. Physical isolation valves are available, but you can simply cut out from the display unit also, because every application and release is by the computer. So you can cut out the whole thing. Now parking brake override. This we will discuss later. What is parking brake? A very, very powerful parking brakes are available here, and it is also potential for problem. There have been problem because of that. Okay. There is a air spring override. It is just the sensor. Those are mechanical system. Whether it is parking brake, it is mechanical system. Air spring, it is mechanical brake, mechanical system, right? So these things are basically their signal communication is cut out from the TCMS. So TCMS will not bother about that. So TCMS will ignore the signals that these sensors are not working. Okay. Then there is a AC control. I just told you that all the AC can be controlled right from the driver's desk, right? So load balancing, switching on and off, everything can be done from the driver's desk. Is it visible to you all? Because I am going last 3-4 slides.
Visible, sir.
These are the basic
visible,
functions. Yeah, these are very, very basic functions of TCMS, because it's a backbone of the control system of train. So, and then door control setting. See, system definitely requires the doors to be closed. But let's say one of the door has got some mechanical problem, or it has got sensor problem. Then even though it has been closed, but the system is not detecting its close status, like in this case, R1 is being shown in the first TC, right? So what you do, you can override that. So if there is a permanent problem with these doors, it can be overridden, and it can be the system can bypass that and still start the train. Or on the other side, individual doors can be opened. Right now, the system opens all the door, either left side or right side, one side. Why one side? Because platform will be only at one side. Isn't it? Platform will be either left side or right side. So one side doors can be opened, and the system works by default by opening all the doors at one side, either side. So that default behavior can be overridden. One specific door can be opened or closed. That is also possible through the driver's control desk, right? Then we have pantograph control, VCB control. There are VCB before pantograph and there is a VCB after pantograph. I think it should have been covered in your propulsion circuit or power circuit. So I'll not go into that. There are dual VCB on either side of the pantograph. That also can be controlled here. Then there is the most important controller is the master controller. It does the traction control, regenerative braking, total brake calculation, blending of brake, right? And interfacing with the brake control. So there is electronic circuitry. It does simply interface with that. Okay. So it is interfacing with, I told you already, it can control the whole RMPU, but RMPU gives the feedback back to this thing, TCMS. There are few things. Say, for example, if a coach gets fire, it catches fire. So in case if there is any fire in a coach, then how AC will work? The blower will be reversed and AC unit will be shut down. But how does it gives feedback to the TCMS? Through the same interface. So there is a lot more. It is not only control. There is a feedback part also, right? Okay. Now, what are the other things? Safety system. So the rollback is not permitted here. If the rollback is detected, right? If the train is standing and it is as per the key position, as per occupied driving DTC position, there is an occupied DTC and there is an unoccupied DTC. Which one is occupied DTC? Anybody? There are two DTC.
Leading cab.
Leading side is occupied.
Leading cab is
Yeah, the other side there will be guard. Even that will be occupied cab, but it will be occupied by the guard. So when you say the occupied DTC, that means there are loco-pilot and co-pilot, and the train is moving in that direction. It is the key is set in such a way for the train to move in that direction. It is the occupied cab. So if the train starts rolling in the other direction, whatever is the reason for that, something is pushing, or there is a gradient, right? Anything. If the train rolls into the opposite direction rather than the key position, then the system automatically detects that and it applies the brake. So even if you leave your train unattended, that of course loco pilots don't do, and a condition of rollback happens, system will stop that. There is a vigilance control. Our loco pilot people from the loco side know very well what is the vigilance control. It is to ensure that the loco pilot is not sleeping or it is not in any way incapacitated. Incapacitated means maybe there is a heart attack, maybe there is some ailment, maybe there is whatever is the reason the driver or the LP and ALP both are incapacitated. there is a system which keeps on monitoring their actions. There are certain actions like throttling up, throttling down, application of brake, release, sounding of horns, and etc. So if any of these things are done, then system knows somebody is operating it. If all of these basic controls are not touched upon, then the system waits for a certain period, then it sounds an alarm, right? First visual indication, then visual indication with alarm, and after that it applies the brake and brings the train to a stop. So the loco pilots must always be active. So this is the vigilance control that is available in the locomotive. It is same thing is available here. The timings are same. All train level protection, that is there is a loop back, emergency brake loop back, right? So in case of any parting or anything, digital signal loop back is broken. You don't have to depend on the pneumatic parting of the train. Digital signal loop back is also broken. That means train has parted somehow. So that is train level protection is available here. Then there are automatic train controls. About cruise control. It is available in automobile. It started with the marine ships. Later on into aero traffic, aeroplane, etc. And now it is in automobile also. The same thing is available here also. It's called cruise control. You simply set the speed, and the computer will decide how much acceleration or deceleration is required to keep that speed constant, right? So you set a speed and let the control system to drive the train at that speed. So that is cruise control. Again, a lot of things are automatic here. Then there is a neutral section control. In the olden days, neutral section used to be very, very long, and then loco pilot was supposed to carefully watch it because it would be displayed on the poles. Neutral section is starting, the neutral section is ending, and so on. Now, neutral section control is basically, if the data is fed into that, all the neutral section control is GPS based. So the train knows where is the neutral section, where it starts and where it ends. Right? So these are all automatic train controls which are built into that. And then there are centralized controls, right? That we have discussed a lot. Right through the driver display unit, they can isolate the door, they can isolate the motors, bogies, whole basic unit, down the panto, control the RMPU, and so on. So there is a lots and lots of centralized, even display. You people from CNW side, from the old, not older time, we are still maintaining that. Changing of destination board, how difficult it is. If the rake is not running in the same route, if your rake is running on more than one route, then you have to change the destination board. वो आया सारा ट्रेन में एक इस तरफ एक उस तरफ दोनों तरफ सीढ़ी लगा के चढ़िए. You put a ladder and remove all the destination board and fit a new destination board. Is this a problem or not? Anybody? CNW side.
Great problem.
Yes, sir. Exactly, sir. Exactly.
Big problem. And none of the staff wants to do that job, right? Okay.
Right. Simply we are keeping all the arrows to the already.
In this case, everything is electronic. Even the display units are electronic. Right now it is LED based. In the newer design, it is TFT. Even the outside display is supposed to be TFT encased inside the glass. So everything is controlled by the computer. You can keep up to 30 routes. You can keep up to 30 routes saved. You just select which route you want the train to run, and it will show which what train it is running from which station to what station. And there are some display unit inside the coaches. It will say which station is reaching, after how much time the next station will reach, what is the name of the station which has just passed. All that information, nobody has to do anything. It will display everything. It will announce everything. It is automatic. So that is what is route. Then apart from that, there is event recording, of course, data like we have in locomotive. All the technical parameters is recorded and kept for downloading. There is a remote train monitoring also is there. So all the data is transmitted to a centralized server. So even though the train is running, a large amount of data is made available to the maintenance people. They can see how well train is running. So it is for the maintenance people. It is very good in that way, very informative. Now coming to the train line communication, right? Now this is end basic unit. How you can identify it is end basic unit and not a middle basic unit?
Anybody? DTC is there. One
Yeah, it
DTC
is DTC. Otherwise, it will be NDTC, right? Now the component here, we can now look at the bottom. So there are a few things. Now the size of the block does not represent the size of the component. It is a block diagram. It is a block diagram. I'm repeating that. So the size of the box doesn't mean that is a big component. So Ecm switch, that is Ethernet consist network, that is switch. It is a simple Ethernet switch basically. These are industrial switch. They are not like your anybody who is working on computer side would know what is a Ethernet switch. Ethernet switch, anybody? With Cat5 cable or Cat6 cable coming to your computer with RJ45 connector. Remember that? No. Okay. So this is not like computer networking. These are very rugged industrial switches where there are circular socket connectors are there, not RJ45. There are thick cables are available, which are twisted pair again, but it's not like it is a Cat5 standard, but those cables are much more thicker, heavier, and fault free. So these are different kind of switches, but these are very small components. So Ecm switch you are looking at, some few things I will just note here. You see, it is redundant. Can you see there is one switch here and another switch here? It is available everywhere. In each coach you will find there are two switches. So any of the switch becomes defective, other switch keep working. No, the system doesn't bother at all. Clear, everybody? You are able to see that?
Yes.
Yes, sir.
Now you can see another one thing. These Ecm switch, these are nothing but networking switch. They are using Cat5 cable, Cat5 standard cable. They are connected to each other, coach to coach, right? So this passes through the coupler, that electrical coupler. Now you see, it is these switches are connected between the basic unit only. If you want to go beyond the basic unit, then you have Ethernet train backbone switch, right? This is connected to other basic unit. So basic unit to basic unit, the connection is slightly different. And then coaches inside the basic units are connected separately. Okay. This is what I'll just remove that out. And you will also see that each of these coaches, all of them have their control units. And again, those are redundant. There are two of them here. There are two of them here. There are different names are there.
Sir, what is the purpose of Ethernet switch?
Pardon?
What is the purpose for Ethernet switch here?
Okay, I will explain that. Just allow me the liberty to point out one more thing, right? And then I will go back to that and explain that. Now you see here, these are the real controller of that particular coach, right? These are the computers that control everything in that coach. If it is a motor car, that is MC1 and MC2, you can see it is called MCU1 and MCU1R. R is redundant. So this also is double, right? These are the computers. They control absolutely everything. If it is a not motor car, then what they do? They control basically three RS-485 network. So each coach has got its own network, three of them actually. One for control of door, one for control of RMPU, and one for control of brake system. So there are three distinct network available in each coach, right? These are digital network. The standard is RS-485 in case of these individual networks. These networks are controlled by these computers, that is PCU1, PCU1R. So there is a redundancy, there are two computers. So in case of motor car, if you look at this motor car MC1 and MC2, these also control the line and traction converter, right? That means your traction is controlled by these computers. Okay. Now coming back, just remember that we will coach by coach, we will see in little more detail this. Now coming back to that, what is the purpose of these switches? Now the control signal from the master controller, right? Through a computer, of course, we have this, your master controller is this. It is only available in driver's cabin, right? Both side DTC, right? Is a centralized control unit, right? So the master controllers give feedback or signal to centralized control unit to what? The master controller is used for either acceleration or braking. So the digital signal output from CCU is actually conveyed to a network switch. It is, again, Cat5 standard they are following. So anything that is in the Ethernet switch, basically it is this thing, packet, the data packet is basically of TCP IP standard, right? So that 65 KB data packet, the standard, it is same here. So the digital signal in the form of data packet is conveyed to this network switch, and this network switch keeps on sending to all the other network switches. So the control signal, whether the braking is required or motoring is required, in case of motoring, what kind of acceleration is required, in case of braking, how much retarding force is required, that information is conveyed digitally, right, to all the network switches. And from this network switches, it goes to train backbone, Ethernet backbone, and it is conveyed to other basic unit. So the control signals are fully digital. Whether you want to, there is other things. It is not only motoring. It is not only motoring or the braking. It is also the door control, the AC control, the other feedback, the fire suppression control, and so on. So all those things, the communication is digital. Rather than भाई आप अपने मोटरसाइकिल में आप चलाते हैं तो you have accelerator, आप घुमाइए उसको, there is a physical cable wire. That wire goes to the your carburetor. Carburetor में your butterfly valves open proportionate to your twist of the hand. Yes or no?
Yes, sir.
But similar thing in case of locomotive, you have throttle. Throttle where you have master controller. There are basically a lot of cams and connectors inside the body of that your controller, right? So basically there are certain number of switches. This combination tells your electronic control कि what is the throttle setting. So जो आप हाथ से कर रहे थे वायर से, same thing is now through electrical signal. The same thing here is now digital, right? And since it is digital, you can copy it, right? So you can have two switches. And this information goes to and fro, both direction. Why both direction? Because there is a feedback. Every time, this is the beauty of the digital system. Na? You ask the system to do anything and it gives feedback ki matlab, okay, the thing is done or not, thing is happening or not. So that kind of thing. So there is a continuous loop back. So the signal travel in both ways. So within the basic unit, all the control signal travel using Ethernet standard from Ethernet switches to Ethernet switches. And basic unit to basic unit, again, there is a gigabit train backbone network. So it passes through that. And all this information, what is the purpose of this information? This information finally comes to a computer through any of the means. There are two, they are both connected in parallelly. It is not like that ki one of the network is broken and then you will switch on to another network and then you will turn some switch or operate some dip switches. No, nothing. Everything is connected parallelly all the time. If any of the switch is not functioning, computer records which switch is not functioning, but it still keeps working. Every computer is two. If one of the computer is not working, computer is not like your desktop or laptop or it's not like that. These computers are basically they are cards. The whole thing is mounted on a card, system on chip kind of thing, and it is on a rack. We will see how these are actually, what are the cabinets where they are mounted. You can see these are available also in redundancy, two numbers. So if any of the circuit or the computer circuit is not working, other keep on working and the system will not even notice that there is any problem. And then again, it will be in the fault data ki this switch is not working or this cable connection. It is not only switch. Probably your cable connection may be loose or broken or eaten by rat. That should not happen because these are all securely, it is all inside the steel pipes. These cables are not free. It is very, very well secured cabling because that is related to train control. So चूहा तो नहीं खा सकता है, rat cannot eat it. But I am just giving one far-fetched example. Anything that happens to that, the cable is disconnected. It will work through the another circuit. Clear, everybody? No, it may not be that clear right now, but let us talk about coach to coach. It is just how the coaches are connected to each other I am trying to explain. Right? Now let's see the DTC. Now, the important thing here is driver's desk. Is this visible to everybody?
Yes, sir.
Yes, sir.
Now, as I already told you, the size of the block doesn't mean the component is that big. So these Ecm switches are very, very small component. Of course, they are very, very rugged. It's not like your normal Ethernet switches. It is similar to military standard. So the circular socket type connectors are available, not RJ45. So these Ethernet switches, they are two and wired separately and in parallel, right? We already discussed that. But what are the other things? If all of this fails, right? If all of this fails, the digital network, then system goes into RDM, rescue drive mode, right? That is based on frequency. So rather than digital network, now your system will rely on frequency generator. So based on frequency, by modulating the frequency, you can control everything. Now driver don't have to bother. Driver will be only interacting with HMI, that is human machine interface, that is your everything available on your driver's desk. So there is a touch screen and there are certain number of buttons. All these buttons, again, they feed into a centralized control unit, right? Now, if your digital signals are not working, your frequency based system will again feed into the same computer. It is, as they call it, rescue try mode. Though it is called rescue try mode, it does not lose any functionality. So if your digital circuit is not working because of whatever is the reason, of course, there is a redundancy in that. If some of the components are not working, the signal will still be carried through the other component. But let's say we assume that both of them are gone, still your system will work with full capacity, all the speed, all the functionality using the frequency based control system. So there is one frequency generator unit here. That is the third redundancy, right? But the system will record what are the things which are wrong. When the train comes for the maintenance purpose, the maintenance people will identify what is the problem and set right the problem. But system would still work with simply the frequency base. So this is what it is, right? Now there is a speed recorder. We know that it is a simple Medha. Medha started with this. The people from the loco side may remember, right? The Medha started in Indian Railway with one speed recorder that isn't it? First. Yeah. But later on, yes, they made lot of inroad, lot of innovation. Why Medha could do all that, railway could not do. We have got so many production unit workshops and all that. The best of the brains, right? You and me, we are in railway. But anyhow, that is a matter of discussion for some other forum. But yes, this is the Medha speed recorder. It is the same old design with slight modification in that for this. And then, so apart from that, there is a display unit. There is a two computers. There is a train protection system that is built into that. We will discuss about that. There is a passenger information system. These systems we will cover it later again, right? So,
Excuse me, sir.
हाँ जी.
सर ये FGU यूनिट के बारे में समझ में नहीं आया सर. इसमें आपने जैसा बताया फ्रीक्वेंसी बेस्ड है.
हाँ.
तो ये ड्राइवर डेस्क जो है सर, उससे जो सिग्नल हमें मिल रही है वो तो डिजिटल सिग्नल है सर.
नहीं, ड्राइवर डेस्क से जो सिग्नल है that is all analog. It is not single line. You can see this yellow line, na?
Yes, sir.
You are looking at this yellow line. It is not one connection. It is dozens of cables. It's a very big bunch of cable. And from driver's desk, see, you press a button. What you are doing, you are short circuiting a circuit. That's all. Pressing a button is what? You are closing a circuit, right?
Yes, sir.
Your majority of the control at the driver desks are of that type, pressing of button. Whether you want to sound a horn, you want to switch on the headlight, whatever it is. Then you have master controller. Master controller is similar to, if you are aware about master controller in any of the locomotive, whether it is throttle control or it is master controller of HHP locomotive, there is a bunch of cams. So there are wires, right? So the combination of wire indicates what is the setting of your master controller. So again, the signal is very much analog. This analog signal feeds into CCU1, right?
Yes, sir.
Now CCU1, based on that analog input, decides the appropriate digital signal that should go to the rest of the coaches.
Okay, sir, I got it.
You understood now?
No. It means,
Point is, no. Let me complete my whatever I was telling. The point I was making is, if your digital signal from CCU is not reaching to the next coach or train backbone for that matter, we can assume that one of the Ethernet switch is gone or connection. Let us say it is not passing through the second one also. It is not reaching at all. Then all your computers, even the computer which is available even on the DTC, which is PCU1 and PCU1 redundant, right? If they are not getting signal through the green color wire, right? They will search for the signal on blue color wire. Now this blue color wire, in that by simply modulating the frequency, we can convey which component has to do what. The information, rather than going digitally, now it is by the frequency modulation. The information is still reaching your car computer. You can call it car computer or coach computer. It is a computer system which is available in your coach, and these are our 2 number, and it is available in every coach, right? So if the computer doesn't receive any signal through the green connection, it acts upon the connection which is reaching through that blue signal, blue cable, right?
Yes.
So that is frequency based. That's why we call it frequency based operation. If there is a lot of noise in the system, fluctuation, whatever is the reason, if the digital signal is not working, purely frequency based system will still work as a third redundancy. That is why it is called rescue drive mode. The whole drive is rescued now, right? But still it is working with complete capability, full capacity.
Okay, sir.
Okay. So you see, these things are special in the DTC. It will be in both the DTC. These things are common everywhere. Your bottom wala, there is a 3 network. Can you see? There are 3 parallel cables. These are all kind of, what color is that? Purple? It's not purple, dark maroon, right? You can see there are, let me annotate again. There is one here, there is one here, and there is one here, right? There are 3 parallel cables. You see, there is your brake control is connected to 1. Your door control, DCU1 to DCU4, it is written. Is it visible to you? Can you read that?
Yes, sir.
Okay. So DCU1, DCU2, DCU3, DCU4, there has to be 4 actually. They simply write 1 and 4, so 2 and 3 are in between, right? So door control, it is at middle, and then you have RMPU control 1 and 2, right? You have two RMPU. Door control, 1 for each door. RMPU control, 1 for each, right? But your brake system, again there is a redundancy. EBCU1 and EBCU2, that is electronic brake control unit, basically 1 and 2, they are parallel. They are parallel. So even the brake control units are double. One fails, the second will keep working. Your driver will not even know the difference. Maintenance people will know, right? Clear? So you will find that this is available in all the coaches. Why? You have door control in all the coaches. You have RMPU control, that is roof mounted packaged unit. No, it's a AC control basically, RMPU. Nobody is asking. Everybody understood. No, I thought everybody understood what is RMPU.
Yes.
Yes, no?
Yes, sir.
Okay. So I hope that 130, 135 people understand that RMPU is roof mount and everything else. So there is an individual control for each AC unit, individual control for each door unit, and redundant control for the brake unit. And it is available in all the coaches. Exactly the same thing. The rest of the thing will change. So we go major component of we discussed that already. So I will not go much into that. Driver's desk, we have shown what are the major component in that. I'm not going into each button. That is also available. If I start listing, it will be, then we will just leave it at that. So major control on driver's desk is basically speed. Driver display unit, which is, it acts like a centralized control, right? And the master controller. So digital signal through 2 Ecm switch. This is through A and G coupler. Whatever we were looking at ECN SW, na? That is through A and G couplers. We discussed coupler, if you remember. Remember that A and G coupler? Initially, how many couplers are there? I just shown that it is available on that. We will share this whole material.
Yes, sir.
Yeah.
8 couplers.
Yeah. All right. And then train line signal through F1 and F2 coupler, right? And the frequency signal Again, the frequency signal is along with the train line. Couplers are same, right? Okay. So this is how the control is connected. This is the control panel in DTC. It is behind the driver. जहाँ driver बैठता है, driver's chair you have seen that rear side we have not shown. It is mounted onto the wall itself. It is flushed with the wall. So it is behind the loco pilots, right? The front and rear. So this is inside view, right? So these are basically. What happened? Sorry. Yeah. So these are additional item in Loco Pilot. These are basically the centralized control units, the computers, right? Networking switches, headlight controller, right? This thing, train protection, and so on. This is the rear of that. So this is a cabinet. This is for connecting all the cables. So all cables are connected from outside from the circular socket type connector. So it is very easy to disconnect and reconnect again. The whole thing. Very, very modular design. Okay. Now we go back in all other coaches. So what are the common things which are available in all the coaches? I already told you, brake control unit, it is redundant. 2 of them are there, right? It is through the network. So this is brake network is available. Then door control unit, and then RMPU, that is the AC control unit. These are 3 individual network. It is available in all the coaches. It uses RS 485 485A standard. Okay. So these are connected through Ecm Switch. Right. Okay. So it is common. Now motor coach. See, you remove all those display unit, CCU1, CCU2, driver desk, FGU unit, speed recorder, all those things you remove out. Then cut portion is, again, these computers are quite similar, but they are repurposed. Their software is different, right? And their control is different. They control LTC. Now we know that it is a 3-phase AC IGBT based inverters are available, right? So basically you reduce your 25 kV into something like around 1000 volt, I think 960 volt or so, right? And that 800, it changes, 600 volt also it can be. So that basically the step down voltage from the line transformer, right, is conveyed to LTC, that is line and traction converter. So in line and traction converter, that AC is first rectified, then using there is a DC booster, that voltage is maintained fixed at 1800 volt, right? 1800 volt is fed into the inverter, IGBT based inverter. There are 3 units. So each creates a phase. So 3-phase output is created. But based on that firing of duty cycle of IGBT, you control what is the frequency, right? And what is the voltage. So variable frequency, variable voltage it is called. This thing is again fed to the computer. So the control of LTC is done by this computer. And who says this computer ki how much should be speed, right? It is done by the master controller that Loco Pilot is operating, and digital signal is reaching to this switch. That switch conveys it to the computer, which is available in the coach. In turn, that computer controls the LTC, and it goes both way. It is not shown here. There are 2 of them. This is redundant. R means it is simply redundant. There are 2 of them. Any one of can do all the job. Clear, everybody?
Yes, sir.
Right. Haji?
If IG fail or LTC will fail, then what happened?
No, pardon. Could you repeat your question, please?
If failure occurred in LTC, then what happened?
You have to isolate that particular motor coach, the whole motor coach. Okay. If LTC fails, if your converter fails, your motors are not going to work, right? And they are not going to work for motoring. They are not going to work for regenerative braking. Both sides, they won't work. But not much will happen because you will be isolating one of the motor coaches. So how many motor coaches are available? 2 per basic unit. That means there are 8 motor coaches. If you isolate one of the motor coaches, 7 motor coaches will still be working. Your train will run with full potential, with full speed. Probably acceleration will be slightly slower now because you have lost one of the motor coaches, right? At least 1/8 of the power you have lost. So your acceleration will be slightly less. But still your train will work with all the capability, everything, all the load, all the speed, all the distance, everything. Clear? Was there any question in that? I'm sorry, that couldn't hear that. Okay, maybe not directed to me. All right, okay. So this is how the digital signal reaches through the networking switches to the motor coach controlling unit. Motor coach controlling unit in turn controls the LTC. LTC gets the voltage, AC voltage from your traction transformer. At the end of it, it is connected to the motors. So it works both ways for regeneration of regenerative braking and motoring. Now, this is what is special in the motoring coaches. We know this is common. We know that it will be same in all the coaches. So it will be repeating again and again. Okay. So same thing, it says that it is connected to Ecm Switch, right? Cat5, sorry. It is a Cat5 cabling basically. So it is TCP IP standard packets will be used for that. Medha is not going to tell us what kind of the information they are transmitting, what kind of digital signal they are transmitting, because that is proprietary. But at the maintenance side, you can, if you want, you can simply connect one laptop with that and see the signal, put some wires or packet inspectors, and then you can see inside the packet what are the data that is available. But it is similar to whatever is goes through the Ethernet switch. Okay. So what are the other things?
That data encrypted?
To some extent, it might be, but they have not told much details about their computer system. What kind of processor they are doing, what kind of IO they are using, what is the real-time operating system that they are using. It has to be RTOS, real-time OS, right? So those things they want to keep close to their chest. Some of these things we had questioned them already. Either those people who are explaining that to us were not aware, or they don't want to tell. We will know later. It is only 2 rakes right now. But you see, this rake maintenance requires, lot of information. See, some of the things are by muscle memory you will do in any case. See, आपको brake adjust करना है. You have to detach the coaches or reattach the coaches. You know, number of bolts, connectors, couplers that needs to be connected. The item that needs to be checked, diameter, wheel profile, right? All those things. Those are by muscle memory. We know that already. But where the actual control system, connection of the system, the functioning of the individual components, right now, even during the maintenance, it is being maintained by the Medha. Right? Particularly the software side, the computer systems related things. So unless more rakes come into the circulation, we don't know much about that right now, what goes inside that. But given time and this thing, we will know. Yes, that is
Okay, sir. And sir, there is one FGU unit, that is
Huh.
frequency generator unit,
Yes.
and that sends control signals in case the main signal generator fails. So my question
No,
is,
the main digital network fails, then signal frequency based signal generator is used.
yes, sir. And my question is, when one particular side, let's say the digital communication system, it malfunctions, like it has not stopped working, but it is generating some wrong signals. In that case, how does the controller knows which one to rely on? I mean, the frequency generator signal or the digital signal?
Let me put it this way. When you watch YouTube video, any YouTube video, you are watching, you are trying to see the video of, say, Amitabh Bachchan. Can you see the video of Nasiruddin Shah?
And sir, this
Okay.
handshaking will not be
Okay,
successful.
no, I'm sorry. But okay. Why I asked that? Because in case of digital communication, it is two-way communication with a transmission control protocol implemented. That means all the packets that have started have reached the destination or not, that has been ensured, and also the content of the packet, if it is compromised in any way or corrupted in any way, there are the check bits built into each packet. So not only the system ensures, and it is for every digital communication, it is your laptop or desktop or mobile or watching of YouTube video, or everything is using TCP or digital network in the signal communication between the CCU and your coach control unit, whether it is motoring coach control unit or trailing coach control unit, doesn't matter. These all signals must reach in the proper manner, size, and check bits. And if those things are missing, any of the checks are missing, then the system would assume that the digital signal is compromised. Normally the transmission control protocol necessitates that the data packets which are either missing or corrupted are sent back again. So there is a transmission window within that period. If that signal is received again, those packets are received again, the framing can be done. If not, then system assumes that the connection is lost. So it is the quality of the digital network which is very, very robust. Either the signal is available or it is not. It is as simple as that. So if it is not available, that means it is corrupted. In that case, it will search for the frequency signals, frequency-based signals. Then it will rely and work on the frequency-based signal. It will never mistake a corrupted signal as valid signal, or the same way. I mean, so is that clear?
Please, sir. Thank you.
Okay. It is built into the protocol itself. Digital networks are very, very robust, in fact. Can you assume that you are trying to send money, so let's say your parents, or to Amazon for that matter, you want to pay 1700 rupees and system ends up paying 4000 rupees. Can it happen?
No, sir. That is why banking system always use 128-bit SSL encryption. That is why I asked.
No. I'm not talking about encryption. Encryption is just to secure that nobody else is watching that.
Exactly,
so nobody
sir.
knows your password. Forget about the encryption. I'm talking about you want to send 35 or 1700
No, sir.
rupees. System ends up paying 4000 rupees. There is nothing to do with encryption here. Can this
No, sir.
happen? It cannot
Certainly
happen
not.
because digital transmission has got a very, very solid transmission control built into that. Every data packet is accounted for content of every data packet is accounted for. Integrity of each data packet is accounted for. Any of the data packet is missing, those things are requested again, send again, requested again, send again. Everything is there. So it is very, very robust system. Encryption is different thing. Encryption is to prevent unauthorized access to your network, right? Nobody will be able to watch what you are doing, but what you are doing has to be, pakka at first. There should not be any mistake in what you are doing. But once you hide it, that is encryption. So these things are different. But anyhow, at least you know something about the networking, I believe. Actually, RSA encryption is one of the subjects that I used to teach long back.
Sir, AES, okay, AES is also used.
No. The AES is block cipher. We will not take time here for that. AES is block cipher, right? That's different thing. RSA encryption is different thing. That is trapdoor algorithm we are talking about. Not here. You can call me separately and we will discuss separately. Here, the digital network is very, very robust. And there cannot be a mistake in the digital communication unless there is a seriously some problem. Wire is disconnected, the hardware is not working, the circuit has become defective. That kind of things only can disrupt the, digital network. In that case, the computer operates by signal available on the frequency bus. Now there is a problem here. Frequency bus can make wrong assumptions. Frequency bus can have corrupted signal. So that is why in case of frequency bus, the signal has to be far separated from each other. So the noise should not form, noise should not be, misinterpreted as signal. So the frequency based control is slower, much slower when compared to digital signals, but the train still works, right? The other things, they are all same. Only thing is LTC. Okay, this is how it looks like. Control panel in motoring coach or motor car. Again, something else is different here, that is driving end of coach. What is driving end of the coach? Anybody? Driving end of the coach, which side DTC or NDTC is in a basic unit. So these coaches are directional, right? Their coupling is directional. Their orientation is directional. So this is provided at for any basic unit. One side is NDTC or DTC. So these are provided at that end of the coach, right? All the control panels are, whether it is trailing coach or motor coach 1, motor coach 2, they are all located towards the DTC or NDTC coach, wherever it is marshaled. Right? And what are the things that is available here? Now, you see there are some CCTV controls are there, the passenger information system, right? Now there is a, of course, MCU is there. So it's a control panel in MCU. The computers, basically that is MCU and MCUR. Modular circular socket type connectors for keeping it. Okay, now this is the TC. Again, in that there is one more switch. There is one additional switch here. You might notice it here. That is basically, this is Ethernet train backbone switch. Now this connects to other basic unit. So the communication between basic unit to basic unit is through not ECN switches, not here. It is going to other coach of the same basic unit only. So these ECN switches, Ethernet consist network switches, basically they are connecting all the coaches among the basic unit, within the basic unit. but basic unit to basic units are connected using Ethernet train backbone switch. That is separate. Again, it's a gigabit switch. They are quite similar, in fact. Okay, so here we know that these two are the computer. They control the same thing, but there is only one thing extra here. Right? Let me completely remove this out. Anybody say what that is? Anybody can guess? It is a TC.
The auxiliary
What is
control
extra? Selling car. Auxiliary,
control
yes.
unit.
Yes, auxiliary control unit. So there is a again there is a converter for auxiliary systems, and so again there is two type actually. One is fixed frequency and another one is variable frequency. So that is ACU actually controls that. But apart from that, rest of the things are quite similar. There is no motor control in that. There is no LTC control in that. Right? So of course, the same thing is described here. Powering auxiliary converter unit to power the auxiliaries is available here where the control is concerned. Okay. So now let's see how it is. So this is panel. Again, it is at the driving end of the coach. So it is at the driving end of the coach. And again, its CCTV camera is there, passenger information system is there, right? EBCU is there, and then its computer, EPCU, redundant computer, Ethernet backbone. This is one extra item which I have already told you. This is the physical location of that particular item, right? Okay. And then ECN1, ECN2, like any other coach. So these are, so you can see with slight variation, even these control cabinets are also quite similar in their dimension and other things. Some components only change inside that. So in DTC and NDTC, there are some of the things which are common in these both. That is one battery charger, right? BCS, then controller for compressor. These two things are specific to DTC and NDTC because battery bank and compressors are provided in DTC and NDTC. Isn't it? Remember that. So now this is for middle basic unit. It is absolutely safe. Only thing is here special is rather than DTC, it is NDTC. Now, in case of NDTC, you have BCS, you have battery charging system, but you don't have DDU, you don't have speedometer, don't have FGU, you don't have master controller. All those things which are related to Locopilot is not available here, right? But one more thing, if you detach end basic unit, now my question is to you all. If you detach end basic unit, can you drive it? It is self-contained. You want to do some shunting work, you are detached end basic unit. End basic unit means there is a DTC in that. Locopilot can sit there. Can you drive it? Anybody? All computers are there, all NTCs are there, motors are there. It's a basic unit, all 4 coaches. Can you drive it?
No, sir.
Communication will not close. Feedback.
No, you just जहां पर बंद नहीं हो रहा isolate कर दीजिए उसको खत्म के साथ. Yes, you can drive it for shunting purpose.
शंटिंग के लिए कर सकते हैं.
Yes, you can drive it for shunting purpose. End basic unit. What about middle basic unit? Middle basic unit you have removed separately. Can you drive that?
नहीं उसमें कंट्रोल कैब नहीं है ना सर, तो उसको कैसे ड्राइव करेंगे?
Yes. So just for information, because I know that, of course, this is because ICF told us you can drive that. There is a portable controller that they are developing right now. It is not ready yet, by the way. But in future, you can simply plug जो आपका control cabinet है ना. You see each coach has got one control cabinet. So NDTC में जो control cabinet है, the control cabinet available in NDTC, you can plug a portable controller. Everybody knows about EOT crane, right? EOT crane can be of dual control. ऊपर चढ़ के you can climb up in EOT crane and this thing. overhead crane, and then you can operate it. Or there is a portable controller also which hangs from a cable. You can, with portable controller, you can control the EOT crane. Yes or no?
Yes, sir.
Similar to that, not that much similar, little more, it will be little more complex. So it will have pneumatic connector and a electrical connector. You just plug into that control cabinet of NDTC, and you can drive even the NDTC separately with that portable controller. Right now it is not ready yet, because अभी तो दो ही रेक इसके चल रहे हैं ना, जो ट्रायल वाले थे. Basically all the this thing technical specifications have not been fulfilled. So in future, in all the train set will have this capability, and you should be able to shunt the middle basic unit also on its own, provided there is OHE. And it's speed. Clear? Yes,
sir.
no, any question? All right, okay. So apart from
Yes, sir,
this
ठीक है.
NDTC, rest of the things are absolutely same. In fact, MC1 is interchangeable with MC1. MC2 is interchangeable with MC2. MC1 and MC2 are not interchangeable. TC1 is interchangeable with TC1. NDTC is interchangeable with NDTC. DTC is interchangeable with DTC. That is why motor coaches, they have kept MC1 and MC2. Why? Because all the components are same, they should be interchangeable. No, there is some this hardware addressing of the component, because this digital signaling is with hardware address. So hardware addressing is different. So you should be able to change MC1 with MC1 only of other rake, MC2 with MC2. But other than that, components are absolutely same. So this is in NDTC, the control panel. These are the part of control panel inside the NDTC, right? So we will not go much, because these are similar, which we have seen so far. So this is about, we started, 10 minutes late, and we have ended roughly 10 minutes late. So question, please. There is a lot of, computer networking or computer type networking that is going into that. It is only because it is majority of the things, or the control system is digital now, right? So there is a CAN bus. The CAN bus we will discuss, because NOR BRIMSE uses the control area networking, right? They use Cat5, so it will be TCP framing, and then RS485. So there is a lot of computer-based networking is available in that, which controls the whole train. And these are the standard which is followed the world over. It is something that is not new, that has been invented here. It is the basic standard and concepts are available in the train set of latest design the world over. The same thing is being used here. Yes, question please.
Sir, right now available 2 rakes of train 18 is there, na, sir? Now upcoming rakes are train 18 or train set?
Train set. No more train 18. There is a lot of modification, like traction motor cooling has been modified, right? That kind of thing. Like marshalling order, that how NDTC and motor coaches are marshaled, that also has been changed. It is a permanent change. It is not as per your own convenience कि अच्छा ये वाला coach आगे लगा देंगे, ये पीछे लगा देंगे. That cannot happen. It is with a certain marshalling order only. You marshal in any other way, your train will not work. So that even marshalling order has been changed. So there are a lot of changes, in fact. The AC ducts, those things are changed. So some interior portion also. So there is a lot of change from the existing train 18 which are running right now between Delhi Katra and Delhi Varanasi. New train sets will be better.
Yes, sir. Thank you.
Any other question?
Sir, what is going to be the caudal life of these rakes or coaches?
Hold on a second. Let me, okay, wrong this thing. First, yeah. Bring back that screen just if you want any clarifications, then I can bring that here. The codal life of these coaches, I have no idea actually. They said that codal life of LHB coaches are same for this, but that is again open for change. So even the schedule particulars, the Camtech has released what are the items that needs to be checked during various schedule, trip schedule, and so on. Like those things are again not very standard. That is initial one, because there is a lot of change in the component level itself. The schedule attention will again be standardized later on. तो क्या schedule attend करना है, हर schedule में क्या क्या item attend करना है, what is the codal life of the components. Majority of the electronic components don't have codal life. If you look in the locomotive also, electronic components, there is no schedule built into that. You remove and throw it. It is all breakdown maintenance, just like electrical bulb. You know, there is no change frequency for electrical bulb. Similar to that, all of the electronic cards go by that concept. When it stops working, you swap it. Otherwise, let it work. So there is no codal life for them. So something similar to that. Is there any codal life for IGBT inverter in case of HHP loco? Anybody? The people who are from the diesel set. Is there any? It is not.
No, sir.
You keep on working, cooling, cleaning. See, you clean it, and there are cooling systems that cool it. It's a semiconductor power electronics. It will work till the components permits, right? So all the electronic components are similar here also. So the codal life for the shell is similar to LHB. Hold on a second, please. Okay. Hello. Good. Sorry about that. So any other question, please?
No, sir. Thank you.
Okay, all right. And then your last class will be on brake system. So we will discuss in little more detail, keeping the things that we have discussed today. So how the suspension in bogie, how the braking, how the calculation of braking, just concept wise. We will not be looking at actual formula or the electronic circuit, where the dynamic brake, that is regenerative brake, and the pneumatic brake, combined with each other. The circuit, air brake circuit, which biasing system. There is a biasing mechanism available in that, where the weight of the coach actually decides how much the retarding force is required. Those things we will discuss in detail in the next class, and that would be your last class, I think, before the valedictory, right? Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
So I will end the meeting.
Yes, sir.
Okay.